Welcome to Machine Learning Lesson 4.3. In this video, we're going to go through a linear regression example using Python. In the process, we're going to review a development cycle, which won't change as you learn new machine learning models. So let's get to it. So the first step in the development cycle is to simply import your libraries. So we have our pandas libraries, which will allow us to get the information, extract it, manipulate it. We have our matplot library, which will allow us to visualize the information and possibly see some anomalies or trends, outliers that you might not see by simply looking at the numbers. Now we come to our new library, the scikit-learn. That's the one that does the heavy loading of the actual machine learning application. The first thing you can see that we import is a linear regression object that will help us to create that model for us. The next thing is a function. This is a neat function. We could do this by hand, but what this allows us to do is it allows us to take our data set and then split it up so we have a certain portion of the data to use for training and then another portion to use for testing so we can kind of evaluate our model. So let's hit play here and let's see what we're dealing with. Okay, so this is not a new data set. We've worked with this one before. This is the cars data set where we have prices, brand, model, mileage, year. What we're looking to try to do is create a machine learning application that can predict prices. So as with any kind of data, we typically want to explore some statistical information about it. So let's do a df.describe and let's see what we're dealing with. So as you can see here, we have 2,499 cars in our data set with the prices ranging from 0 to roughly about 85,000. The years of the car go from 1973 to 2020. The mileages range from 0 to 1 million. All right, so you can see that there's some spread of our data here. Now, when you create a machine learning model, you might want to reduce your data just to a particular set, and it might improve the accuracy of your model. Having said that, though, you may have to offer that up as a disclaimer when you share your model that the model was created using this type of data. So what we're going to do is we're going to limit our data so we don't include some of these cars that are way out here in terms of mileage. So let's say data equals df.mileage less than, let's say 200,000. Okay. So again, 200,000 is still a very large number. My car is a little over 100,000. Will it make it to 200,000? I doubt it. But again, it's some way to kind of limit some of these outliers. So let's see what we end up with after we've kind of reduced our data set. All right, so you can see here we ended up with 2,452 cars where we originally started with 2,499. So we reduced it by 47 cars. Okay, so hopefully that will help us to improve our model. This is definitely an important step in your machine learning model, being able to get the right data to build your model with. All right, but let's move forward. Again, we could always go back and play with this. So having kind of restricted our data, now we have to actually extract which pieces of information we want to deal with. So we definitely want to deal with prices. So let's do that. So let's say data, prices, and let's do mileages. Sometimes this particular piece of information, which is what we're looking for, sometimes this is referred to as the target, which again, you might see this word being used in some tutorials. And this one is referred to as your features. All right. So the target is what we're looking to get. Features is what we're using to try to predict. All right, the next thing we're going to do is let's go ahead and split our data up now. And we're going to use the train test split. And what does it want? Well, it wants your features. It wants your targets. It wants the size of what you want to use for your testing data, which in our case, we're going to use 20%. And I'm going to add one more thing, which took me a little bit to kind of figure out. Random state equals, I'm going to choose a number 6. Again, from using other languages, I assumed that this was some kind of a seed that you would pass to the function, so it kind of create a random output each time. But it actually isn't. This 6, think of it like an ID, meaning that when you run this at your house with a random of 6, you're going to get the same answers that I get, which really is important. I mean, if you're looking to share your model with somebody else and they want to replicate your results, they need to know how what data you worked with. So that's what the random state lets you do. It lets you kind of specify an ID to your data set that then somebody else can use to replicate your results. All right, so let's go ahead and display D, and let's see what we get back from train test data. Oh, got carried away. This should be just price. And this should just be mileage. Okay, so what is D? What do we get back from train test split? So you can see here, we're getting an array back. An array that has 1,161, which is 80% of our data. So here is our 80% of our data for the mileage. Here's 20% of our data, the 491 of our data for mileage. So you can see here, here's our training data for mileage. Here's our testing data for mileage. Here's our training data for price. And here's our testing data for price. So, and just to kind of show you, because it is an array, we could do something like that. And you can see here, it prints out nicer. We're going to use a feature of Python that's really cool, which is we can assign multiple variables values that come from an array. Because we're going to end up using this a lot, it might make more sense for us to create meaningful names for our variables instead of just using D0 and D1 and so on. So as you saw, the first position is our training data for mileages. Our second position is our testing data for mileage. Our third position is our training data for prices. And our last position is our testing data for prices. And just kind of prove to you, let's just display mileages here. And you'll see we get the exact same information. So I'm going to take this out because I don't want to see that. Okay, so what we've done now, we've split up the data. We are ready to start creating our model. So let's create a variable called LR to represent our linear regression object. And as you recall, this comes from that very first import we had up here from the scikit-learn library, linear regression. So this creates our model, and I want you to see how easy this is. So a linear regression object has a fit function, and the fit function takes two parameters. It takes your features, and it takes your targets. And that's it. So we take the training data that we got up here from the split function for both the mileages and the prices, and we use it to train our linear regression model. Okay, that's it. We have a model. We have a machine learning model ready that can predict. But I would say before we go into that, let's evaluate our model a little bit. So a linear regression object has a score function. And the score function, similar to the fit function, takes two parameters. Except this time, it's going to take the test for the feature and the target prices. And let's see what we get. Okay, not a great model. So we're getting about 25% accuracy using the word loosely, accuracy in terms of our model. But we're going to drive forward. We're going to see how this works out. So having done this is one way that we can kind of visualize our model. Another way would be to use the math plot. So let's do that. So let's do prices, predict, and now we're actually using our model. So linear regression object has a function called predict that will actually predict some values for you. And what we're going to do is we're going to feed it our test data. So we're going to feed it our test data for mileages, and we're going to get a whole array of predictions. So on top of that, let's go ahead and do scatter plot of our original data of mileages and prices. And let's do a plot show. Okay, so this was our original data, and you can see this, it's all over the place. And I don't like the way the dots look, so let's do a little alpha on it. And let's say 0.4. Let's run it again. And the reason for the alpha is that you can see some shading here, so that way when they start to overlap, you can kind of see the density through darkness. Okay, so this was the original data, and you can see it had to be tough for the model to kind of really get any kind of accuracy, because look how dispersed our data is at the lower end. As you get higher, it kind of streams down a little bit, but up here, again, it's hard to create a model with just the mileages. On top of this original data, let's now plot what our model looks like. And what we're going to do is we're going to do a line chart. So let's say mileage test and prices predict. And let's do this as orange, so we kind of see it against the original chart. Oh, mileages. Sorry about that. Okay, so we can see here's our original data, and here is our line of best fit. This was Scikit-learn trying to create the best line possible amongst this dispersed piece of information. You see, it was tough. All right, so we've gotten two ways to kind of look at our information. One, using the score that comes from the linear regression model, and one to actually just simply use Mathplot to visualize, what is our predictive, our prediction look like against the original data. But the pudding's in the proof. So now, again, we don't do machine learning models just so we can create charts. We use it so we can actually predict and see what comes out. So for this, I'm actually going to, well, let me type from scratch. I was going to copy and paste it from my other screen, but it might make sense for us to do it like this, just to kind of see. All right, so I'm going to create a for loop, and I'm going to run my machine learning model against 5 different samples from our data set. So let's do that. So I'm going to say sample data, create a variable, and a data frame has a nice feature called sample, which will simply randomly select one of the things from your data set. So what I'm saying is that sample is actually just going to select one of these rows by randomly. So let's do a print of sample data, and let's just pick out prices, mileage, brand. What else? Let's do model. And then finally, let's do year, just as a way to kind of identify the car. And let's just run this by itself, just make sure that it works, which it didn't. Let's see, where did I? Oh, because it's not prices, it's price. All right, that wasn't too bad. Okay, so you can see here are our random cars. So we got a Dodge Durango, a Dodge Journey, another Dodge Durango, a Chevrolet, a Ford. So you can see these are just random samples, and if we did it again, we would get another set of 5. But what we want to do here is that, okay, here are the original cars. Let's use our machine learning model to predict the price, and let's just visually compare to see how. So predict the price. Let's do curly bracket so I don't forget it. Let's do LR. Predict. We're going to predict now. And we're going to pass it our sample data, mileage. And I think I'm good here. Let's do a little cleanup of, let's do another /n, maybe another /n, just to kind of create a little separation between the different outputs. And let's see what we get. And we get an error, of course. You know, let me switch these over to single quotes. Let's see if that works out. Okay, there we go. So let's take a look at our first car. So this was the actual car. It cost $8,000. I had 51,000 miles. Our model predicted that it would cost $18,000. Okay, so we're off about $10,000 there. Again, if you recall, our accuracy was 25%. So let's look at our next model. We got 26,000. We predicted 4,000. Not great. Now this next one's not too bad. It's in the neighborhood at least. The actual price was 10,000. The predicted price was 14,000. You know, this one's 9 and 21. This one's 16 and 20. So this one's kind of close too. Let's run it again. Let's see what happens with another set of 5. Okay, so this one is not too bad. This is within 5,000. I would consider this one large, 9,000. This one's close. This is within 2,000. This one's very far apart. It's about 15,000 apart. And this one actually came out to be negative. So you're going to run into problems like this too when you do a linear regression model because of the mileage. If you recall, our original data restricted the mileages to less than 200,000, but the car that we just selected was over. So what's happening is that, again, this is just a line of best fit. The line has gone down below because it just kind of keeps on stretching. All right, so let's go back to our presentation. Let's review a little bit of what we've done. So in Machine Learning Lesson 4.3, we ran through an example of linear regression. And we saw it's not great. It's definitely an art to create that right data set to train your model. But we did ultimately create a machine learning application to predict prices. So good luck and enjoy.